Hello, my name is Kuncheng. This is a homework 5 problem 1 presentation for the course probability and stochastic process. So let's do the problem 1. For problem 1, the question provide x and y are independent with we have the function of fx here, fy here, and we have to use two methods to solve the fz, and also the provide z equal to x plus 1. So for the first question, we have to use the convolution method. So we have the convolution method function here. The fz equal to fxz convolution with fyz. So we have the function is the integral from infinite to negative infinite fx alpha times fyz minus alpha and the alpha. Then we can plug in the function fx and fy. So we have the function, the integral from the negative infinite to infinite, like plug in the alpha to the fx and equal to alpha minus 1 times u alpha minus 2 and times fy, plug in the z minus alpha to the fy, and we have the function like u z minus alpha times u z minus alpha minus 1. We have and d alpha, and expanded this one, like we have the function, the integral u alpha minus 1 times here u z minus alpha, the alpha minus this is not time, this is minus and this is minus, and minus integral u alpha minus 1 times u z minus alpha minus 1, the alpha, also minus integral the u alpha here minus 2 times u z minus alpha, the alpha, and plus, because the two negative, like here is u minus like u z minus alpha minus 1, the alpha. Also we can use the formula, like here for this one we can move z to here, move 1 to here, and u alpha minus 1 times z alpha, d alpha times u z minus 1. And similarly we can transfer here, this is minus this is z minus 1, plug in z minus 1 to here, and this is 1, and write u alpha minus 1 and u z minus alpha minus 1 and d alpha times u z minus 2. Similarly here we also can transfer the infinite to the z, and here is 2 because the u is the alpha minus 2 and u z minus alpha, and the alpha times u z minus 2. And the last one is integral minus z minus 1 to 2 because the u alpha minus 2 and u z minus alpha minus 1, the alpha times z minus 3 because this is 2 to z minus 1. And we can solve this. We can get the answer is z minus 1 times z u z minus 1 minus 2 times z minus 2 times u z minus 2 plus z minus 3 times u z minus 3. So this is the convolution method. Is very straightforward. Just plug in and use the function to calculate. And this is the second one. Second method is geometric methods. So for this one, because we know the fx equal ux1 minus ux minus 2. This is the graph. So because if we consider fx equal to ux minus ux minus 1 is here, the difference between these two is just for this one we can just move the right side by 1. So if we consider use this function for the geometric method, is easier. So let's do the question. For the geometric method, we have to consider the several situations. The first one is because we use this one. First one, we have to consider z less than 1. And we can have a graph 1, 1. And we can have the z, we can, because z equal to x plus y, and we have the line in the graph, and we have a z for the y axis. We have z at the x axis, and for the probability x plus y less than z, equal the area, the z square divide 2 and equal fzz. And the capital Fz, but for the small one, Fz equal to the deviation. For the capital Z equal, we just do this like this one is Z. And we have the second situation is Z greater than 1 less than 2. We have the new graph because this is 1, that's a square, and we have the also have the z equal to x plus 1. We have the line here, x plus y, and we have the 2 point z0 at x-axis and 0z at y-axis. And for this question is this situation is the probability x plus y less than z equal to the area of the triangle is the z squared over 2 minus, you see the 2 small triangle is we have 2 small triangle and the height is z minus 1 square and over 2. This the probability of the x plus 1 less than z that equal to capital Fz, and the Fz equal to deviation of the capital Z equal to the minus z plus 2 minus z plus 2. And we have the last situation is z greater than 2. We have the new graph like here. Because the square totally include the triangle, so the probability x plus 1 less than z equal to 1 equal to capital Z, and the Fz equal to 0. So according to the 3 function, in summary we can get the graph of Fz is from the z less than 1, we have the z, this is z, we have the line of the z, that's the function, and also we have minus plus 2 from the 1 to 2, that's 0, 1, 2, and otherwise we got the 0. So we have the graph. So come back to the before. We have the fx equal, because we move to left by one unit to use this function. So now we can take them back. We just move to right by 1 unit. We can get this graph Fz. That's 1, that's 2, that's 3. So this is the function of the Fz for this question, and we can get the outcome is Fz equal to z minus 1 u z minus 1 times minus 2 z minus 2 u z minus 2 and plus z minus 3 times u z minus 3. That's it.